as we work through these problems in this chapter. So you might as well have it, you know, up here right now. So what we're going to talk about today is determining whether chiral center is R or S. And there's two systems. There's two systems. There's what I call the dash and wedge. And if I was a chemistry god, which I'm not, we would just go with this, with the standard dash and wedge. Okay? But since it's not up to me, we still have to deal with Fisher projections. And where do you see that? Biochemistry. Biochemistry still uses this Fisher system, so you have to know both. And so we're going to go over both. This is mainly this Fisher system is mainly used in carbohydrates and amino acids, but you have to know both of them. So we're going to look at it. The other thing you have to be able to do is jump from one to the other, move back and forth. And so we're not going to quite get there today, but we're going to be there on Wednesday of next week, and we're going to start looking at problems going back and forth between these two systems. As I said, it would be a lot easier. It would be a lot easier if the people that like high impact folks, would just make a decision. It's either one way or the other, but they keep wrestling about this, and they've been wrestling about it for 20 years. So I don't think anybody's going to make a decision. And so you just have to know both of them. Okay, so what we're going to do today is we're going to look at this R and S nomenclature for both dash and wedge type of compounds. And this is an example of a dash and wedge, where it's showing this group here, this sort of carbon backbone, is in the plane of the board, and then there's going to be two groups, one going behind the plane of the board and one coming out of the plane of the board. And that's what I refer to as the dash and wedge. Okay, and this happens to be an amino acid, happens to be alanine. What it's telling you is the amino group's coming out towards your eye, and that's why when we started talking about the cyclohexanes and the structures with those, we started talking about dash and wedge and how you look at these structures, how you visualize it, because it comes to play here. Okay, so this system is based on what's called the Kahn-Ingold-Prelog convention, and that's used, by the way, it's used both for the dash and wedge convention, and it's also used with the Fisher projection. So if you learn that and kind of figure it out, you've got both of them sort of figured out, and you're in pretty good shape. But it's a way of prioritizing these groups that are attached to these various carbons, and it's based on atomic number. Now, you guys know enough of the atomic numbers. You don't have to worry about, you can pretty much make a call on most of these. And on exams, I'll give you the atomic number, a chart that has most of them on, so you can look at that and make sure you have the right prioritization. So there's a lot of gobbledygook on this slide, but basically it's what it is the priority list, and it's based on atomic number. And I've put on here atoms that you would typically see in organic molecules, starting with iodine. Okay, most of the stuff we're going to talk about is right down here. Okay, right in this region here. But we do talk from time to time with chlorine and bromine. But it's based on atomic number. And the higher the atomic number, the higher the priority. Okay, so obviously if you have iodine in there, based on this slide, that would get the highest priority. And you're going to number the groups that are attached to that chiral center 1 through 4. Remember, you have to have 4 different groups attached, so you number them 1 through 4. So here's some cases. What do you do when you run into this all the time? So how do you prioritize things? So I just want to look at some examples. We're going to look at a whole bunch of these, so I think you'll become familiar with it. So in this case, you've got an isopropyl group attached. That's what the squiggly line means, that you've got these two groups attached to a chiral center. Okay? And then over here, you have an ethyl group attached. Okay, let's suppose you have those two groups attached. How do you prioritize them? Well, the first thing you do is you move out to the carbon, first carbon away from the chiral center. Okay? And you evaluate that atom. Well, if you look at this carbon And this carbon, okay, they're both carbon, so you can't really make a decision on that because they both have atomic number 6, right? So you can't really make a call there. Now you start looking at what's attached to it. What's attached to it? Well, if you look out here, you've got another carbon attached, you've got another carbon attached here, okay? But if you look here, you've got hydrogen, you got one hydrogen over here, but you've got a second carbon here, okay? So there's one more carbon attached here than there is over here on this atom right here. So carbon takes precedence, atomic number 6, over hydrogen. So the isopropyl would get a higher priority number than the ethyl group, okay? So you just keep moving away until you find a difference. And sometimes, we're going to look at an example today, you have to go 2, 3 atoms away from a chiral center to find a difference. And then you prioritize on whatever that atom, or whichever side has a higher priority number, well, you'll give it a higher number in the priority list. Here's an example down here. Let's say we've got ethyl versus an ethyl bromo. So again, if you look, and again, we're talking both of these groups are attached to a chiral center. And we're trying to evaluate which one gets a higher priority number. So if you look here, both have a CH2, can't make a decision there. Okay, we go to the next one, we got a carbon here, a carbon here. This one has 3 hydrogens attached to it, but if you come over here and look, you've got 2 hydrogens and a bromine. And the bromine is going to trump what's on here, the hydrogen that's on here. You go up here, you look at your chart, you see the bromine's like, what, it's 53. So it's a much higher atomic number. So in prioritizing this ethyl bromo would get a higher priority number than an ethyl. Now there's one thing down here, I just want to mention this. You see this from time to time, it's not that often. I probably can count on one hand the number of times I've ran into this looking at these chiral molecules over the years. One high priority atom takes priority over any number of lower ones. And the best example is right here. Okay, so if you come out, again, let's say you've got this methyl bromide versus a dichloromethyl group attached to a chiral center. So if you look here, this carbon, there's a carbon both places. That you can't make a call on that. But then you look at what are the atoms that are attached to that carbon. And if you look here, you've got a bromine here. And over here, you've got 2 chlorines. But because the bromine is a much higher priority number than the chlorines, even though you've got 2 of them, this will take priority over this. Okay? And that's about the only time you run into that. Okay? This goes on. You can look at other examples to this, but that's probably the best one to take account of. Okay, here's another trick. Wade has this in the book. I like this. I use it myself when I'm looking at these molecules. Sometimes it's hard to make a decision when you have functional groups present in a molecule. How do you prioritize it? So these guys have come up with this. IUPAC people have come up with this way. I call it a way to break down these functional groups. So if you have an alkene group attached, again, this is a chiral center over here. What they do is essentially they're going to break this double bond here. They're going to attach a carbon here and a carbon here. And where this comes into play is when you go to prioritize these chiral centers. So what they do is they attach a carbon here and a carbon here. Okay? Let's jump down where we're talking about these double bonds or triple bonds, pi bonds. Let's look down here at acetylene. Okay, again, if you've got an acetylene group attached to the chiral center, what they do here is they break each one of those pi bonds and they attach 4 carbons, 2 at each carbon. Okay? And again, it's a way to prioritize. It's a way to help you prioritize when you have these functional groups attached. And then another one example is this is an imine. So what they do is you've got essentially a pi bond here. So to this carbon you're going to attach a nitrogen, and this carbon here you're going to attach a carbon. Okay. Down here, the carbonyl. This happens to be a carboxylic acid, but it works if it's an aldehyde, an amide, anything like that. You can do the same thing. So what you do is, I'm making this point here, is you leave the hydroxyl group. You don't have to worry about that. But you come back and attach to this carbon here an oxygen, and you attach a carbon to this oxygen. So that's what the red is trying to show you is you attach an oxygen here and a carbon. And we're going to look at some examples on how you prioritize it. I generally do this, break these down. Now I've had students in here over the years that we do enough of these that they become very familiar. They know a carboxylic acid has a higher priority than a aldehyde, and so after a while, some students get to the point they don't even use it, but I still use it. I like this system. Okay, so let's go on and look at what I was talking about up here, R and S, and what this CW. All right, it's not a country western singer or anything. CW means clockwise. CCW means counterclockwise. Okay, and the standard dash and wedge. The standard dash and wedge is where priority number 4 is going away from your eye. Okay, and number 1 is essentially coming out. Okay, so how do we get to this? And then we're going to talk about this. I like this because when you have to redraw some of these where number 4 happens to be coming out towards your eye, people make mistakes. So this is a way to do this without having to redraw these structures so they're in the right sort of configuration so you can look at them. So here's how you figure them out. Okay, so this is showing you a chiral center right here. Okay, what you do is, again, you prioritize based on atomic number the groups that are attached there. Okay, and then number 4, sort of tucked back underneath here, is going away from your eye. And then you're going to go 1, 2, 3 in that order. So this is not priority number 1, number 2, and number 3. And if it's going in a clockwise manner, that's the R in Antomir. Okay? So clockwise is R. That's sort of the shortcut for this. Okay? Now, let's look down here, the S in Antomir. Again, same idea. Number 4 is going back behind the plane of the board. This purple one sort of tucked back underneath here is number 4, and then you go 1, 2, 3 in this direction. Okay, so now it's counterclockwise, and that's going to be the S in Antomir. Okay, and that's why that's where this comes from. This is not dash and wedge yet, but we're going to look at that in a minute. Okay, so here's some examples. Here's a number of examples. So let's just walk through every one of these. Okay, so if you prioritize the groups that are attached to the chiral center. Okay, so number 1, again, I have the atomic numbers here, so you can look at that. Number 1 is going to be the fluorine because of the atomic number of 9. Nitrogen's going to be number 2, okay, because it's a 7, and carbon's going to be number 3 because it's a 6. So you go through the atomic numbers, attach 1 through 4. Obviously, hydrogen is going away from you back behind the plane of the board. So that's set up perfectly in what we were looking at in that previous slide. So number 4 is going away, number 2 is coming out. So let's look and see which direction this goes. So we're going to go 1, 2, 3 in this direction. So it almost looks like you're jumping over number 4. It looks like you're hopping over it. But in reality, it's back behind the plane of the board. Okay? So it's away from you. So you're not really jumping over it, even though in this picture it almost looks like you're taking one step over it. But we're going in a counterclockwise manner. You're going this way. So if it's counterclockwise, it's a standard, what I call standard dash and wedge. Number 4 is going away from you. If you look at this, that's going to be the S in Antomir. Now, if you would reverse this, if you would reverse that, in other words, this chiral center would be reversed, then it would be the S in Antomir, okay? I mean the R in Antomir. So let's go down here. Let's go down here and take a look. Here, just another amino acid. Again, I broke this down, all right? The carbonyl of the carboxylic acid. And again, this is why, you know, a couple chapters ago we started looking at what these functional groups look like, because even though we haven't got to the point where we're talking about how do you make carboxylic acids or the reactions that carboxylic acids do, we're going to start putting them into molecules and looking at them in other directions or in other ways. So in this case, I broke down the carboxylic acid here. So then I'm going to go ahead and probably wouldn't have had to do it here, but I'm going to go ahead and prioritize this, again, based on atomic number. So again, number 1 is going to be the amino group. If you're looking at an amino group versus a carbon and a carbon, so the amino group is going to get the higher priority. I'm giving it number 1. I usually try to do number 1 and 4 right off the bat. If it's got a hydrogen on it, obviously hydrogen's gonna be number 4. And then you have to make a decision between these two here. This one has a CH3 group, right? There's 3 hydrogens here. This one, again, has a carbon, but essentially it's got 3 oxygens attached to it. So this carboxyl group takes priority over this methyl group. So this is gonna be number 2, and this is gonna be number 3. And again, we're gonna sort of look at a steering wheel. Some people think about it that way. So we're going in the direction of 1, 2, 3 in this direction. But again, it sort of looks like you're jumping over number 4, but remember, number 4 is going away from you, back behind the plane of the board. So it's not like you're really jumping over it. So it's going 1, 2, 3, and again, we're going in a counterclockwise direction. So that's going to be counterclockwise. Come back over here. Look at your chart. So this is going to be the S enantiomer. Okay. Let's go over here and take a look. Let's look at this molecule. Again, the chiral center's here. You got 4 different groups attached. I think we all agree on that. Number 4 is going to be the hydrogen, so you get that out of the way right away. And now we're going to start looking at the carbon groups that are attached. So there's a carbon here, here, and here. Okay, they're all going to be 6. Okay, you can't really make a decision from that. But the number 1, if you look at this carbon here, has another carbon attached to it. So this has 2 hydrogens. This has 2 hydrogens. This has 1 hydrogen, and then a second carbon out here. So it's going to take priority over both of these. And then we jump out another carbon. Okay, we've taken care of this. We're going to jump out another carbon, so we're going to come out here, and we're looking at this carbon and this carbon here. Okay? And this one up here has a bromine. This has 3 hydrogens, but this has 1 bromine up here. So bromine takes priority, atomic number 53, over hydrogen. So this will be number 2. This will be number 3, and again, we're gonna go in this direction, counterclockwise. So this is going to be the S enantiomer. Again, it's what I call the standard dash and wedge, where number 4 is going back behind the plane of the board. Number 1 happens to be coming out towards you. And as I said, it looks like you're sort of jumping over number 4, but remember, it's behind the plane of the board. It's back behind. So here's your steering wheel. Here's the sort of going down. You know, you're driving. Here's number 4 is like that. I don't know, what do you call it, the driving column of your car, right? Something like that. The steering column is going away from you. That's number 4.